Okay, just picture this for a second. Your application is humming along, everything's looking great. And then, bam, out of nowhere, a huge wave of traffic just slams into your system. You know, it's at one moment that really decides if your system is going to stand tall or fall flat. Today, we're going to build a Kubernetes architecture that doesn't just survive these moments, it actually thrives on them. And look, we're not talking about a little bump in traffic. We're talking about a sudden 10x spike. Maybe your latest marketing campaign just went viral, or a big sale just kicked off without the right design. This is exactly when the alerts start screaming, pagers go off, and all your customers see are error pages. It's pure chaos. Hey everyone, welcome to vcloudlabs. All right, let's get right into it. Our mission today is simple, but it's super important. We're going to walk through a real, practical, layered strategy to turn your Kubernetes cluster into a fortress, one that can handle those insane traffic spikes gracefully and, get this, automatically. Now, I know what you might be thinking, wait a minute, doesn't Kubernetes already handle scaling for me? And you're right, it does. But, and this is a big but, its standard tools are often just not fast enough for these sudden bursts. By default, pods can take way too long to scale up. That leads to overloaded services, which then kicks off this awful domino effect of cascading failures all across your system. We need to be smarter than that. So, how do we actually get ahead of the chaos instead of just reacting to it when it's already too late? What's our game plan for building a system that's truly resilient? Our whole strategy really rests on two incredibly powerful ideas. First, scaled elasticity. That's our ability to rapidly, and I mean rapidly, expand our capacity to meet the demand. And second, graceful degradation, which is the intelligence to know our own limits and handle any overload in a controlled, predictable way. So let's break down how we do this, layer by layer. All right, layer one. This is our first wall of defense, and it is all about one thing, absorption. We want to take that initial violent punch from a traffic spike and just soften it. We're going to turn that sudden burst into a manageable, steady flow of work for our system. And this right here, this is a huge shift in thinking. The standard horizontal pod autoscaler, the HPA, it's totally reactive. It waits to see symptoms, like your CPU is already screaming at 90% before it does anything. By then, it's kind of late. But KEDA, which stands for Kubernetes Event-Driven Autoscaling, is proactive. It looks at the cause, the actual backlog of work, like a message queue that's getting longer and longer, and it scales your services before they get overwhelmed. And this is exactly why KEDA works so well. We use message queues as these giant shock absorbers for our system. So instead of all that traffic hammering our services directly, the spike just fills up a queue. This gives us a buffer, a breathing room that turns a sudden, overwhelming flood of requests into a nice, steady backlog that we can work through at a sane pace. So let's just walk through this. It's beautiful. Step one, the spike hits and immediately starts filling up the queue. Step two, KEDA, which is always watching that queue, sees the backlog growing and instantly starts spinning up new consumer pods to handle the work. And then, as those new pods come online, they start chipping away at the queue, and the backlog just drains away safely. All of this happens without a single one of your core services getting overwhelmed. But look, just throwing a queue in there isn't enough. You've got to do it right. It is absolutely crucial to track your queue lag and have alerts on it so you know exactly how far behind you are. And you need a solid plan for failed messages. That's where dead letter queues, or DLQs, come in. Think of a DLQ as a special inbox for any message that fails to process correctly. Instead of just vanishing into thin air, it gets sent here so you can investigate later. You never lose critical data. Okay, so our absorption layer is fantastic. But what happens when the spike is so unbelievably massive that even our scaled up system can't keep up? Well, that's where our second layer comes into play, surviving the overload by degrading gracefully. I absolutely love this quote. Just think about it for a second. Autoscaling is amazing, but it's not instant, right? It takes time for pods to get scheduled and for containers to start up. Overprovisioning is just deliberately keeping a little bit of spare capacity on hand. It's not waste, it's insurance. It buys you those critical few seconds or minutes for your autoscaling to kick in. And believe me, the cost of that insurance is almost always way, way cheaper than the cost of a full-blown outage. And Kubernetes gives us the perfect tools for this. With things like pod priority and resource quota, you can literally tell the scheduler, hey, these services over here, they're my VIPs. So when things get tight and resources are scarce, Kubernetes knows to give CPU and memory to your most important workloads first, making sure they stay alive even when the whole cluster is under crazy amounts of stress. But even with that extra capacity, you might still hit a hard limit. And at this point, you have a choice to make. You can either let your entire system just collapse into a fiery mess of timeouts and failures, or you can make a smart, controlled decision to protect it. And that decision is called load shedding. So, load shedding just means we're strategically dropping some traffic to save the rest. First up, you can use ingress rate limiting, which is like putting a bouncer at the front door of your club. It puts a hard cap on requests before they even get inside your system. Next, you can use a service mesh like Istio or Linkerd to implement circuit breaking. This is like a fuse box for your microservices. If one service starts to fail, the circuit breaker trips, isolating it so it can't take everything else down with it. And finally, you can use API gateway throttling to enforce really specific limits, maybe per user or even per tenant. The goal here is to fail fast and predictably for some so you can keep succeeding for your most critical users. So let's zoom out and put all of these pieces together. We've gone through our two main layers of defense, and now we can see the whole strategy taking shape. This isn't just a random collection of tools, it's a multi layered defense system designed to make your application fundamentally more resilient. So let's recap. First, we absorb that initial shock using proactive, event driven autoscaling with KEDA and message queues. Second, we survive that inevitable scaling delay by strategically over provisioning for our most critical services using pod priority. And finally, if all else fails, we degrade gracefully with intelligent load shedding. And what's the result of all this? Your critical functions stay available and your system stays stable no matter what the world throws at it. And really, this is the main thing I want you to take away today. You can't always predict when a huge traffic spike is going to happen. They are inevitable, but you absolutely can and should design a system that expects them. With the right architecture, outages are not inevitable. They are a choice. Thank you so much for watching this explainer. If you found this helpful, please be sure to follow vCloudlabs for more deep dives just like this one. And maybe ask yourself, is your system built to withstand the inevitable? Or is it just waiting for the next big outage?